Let's take derivatives and integrals of polynomials of arbitrary degree using matrix multiplication, using linear algebra. Let's start with derivatives of polynomials of degree less or equal to n. Notice that derivation is a linear map, and if I pick a basis, 1x, x squared up to x to the n, then I can write it in coordinates with respect to that basis. In order to compute the matrix for the linear map, that is derivation, I need to know what happens to the basis vectors. And since the derivative of x to the k is k times x to the k minus 1, that means that the basis vector x to the k goes to the previous basis vector multiplied by k. So that means that this basis vector in coordinates goes to this other one. The one with a 1 in the kth coordinate goes to the one with a k in the k minus 1th coordinate. And then the matrix for the linear map is just given by a matrix whose columns are the image of the basis vectors. So we've seen what the image is of each vector, and then the matrix will be that. So now if I have a polynomial a0 plus a1x plus a2x squared, I can just multiply those coefficients by this matrix and get the derivative of that polynomial. So what about integration of polynomials? I want to go from p of x to the integral from 0 to x of p of t dt. Can I put this in coordinates? Now, for integration, polynomials of degree n will go to polynomials of degree n plus 1. So actually here I'm going to just use an infinite dimensional vector space, which is Rx, with respect to the basis 1x, x squared, powers of x, and write an infinite matrix that gives me the images of x to the k. X to the k should map to x to the k plus 1 divided by k plus 1. So the matrix is like so. And then I can use multiplication by this matrix I to do integration of polynomials. For example, if I take the polynomial 2 plus 3x squared plus 5x to the 7, these would be the coordinates for such a polynomial. And notice that there are zeros. After that, 5 is all zeros, infinitely many zeros. But if I multiply I by that vector, what I will get is that other vector, which is the integral from 0 to x of the polynomial p of x. So the answer is 2x plus x cubed plus 5/8 of x to the 8.